Year 13 short revision video number 15. So we have some probability here. Every morning before breakfast, Laura and Mike play a game of chess. The probability that Laura wins is 0.7. The outcome of any particular game is independent of the outcome of other games. Calculate the probability that in the next 20 games, Laura wins exactly 14, Laura wins at least 14. So this is setting us up very nicely to look at a binomial distribution here. We have games that are independently played, so the outcome of one game is independent of the outcome of other games. The probability that Laura wins remains consistent at 0.7, and we have two outcomes here. Laura winning, 0.07 probability, Laura not winning, 0.3 probability. And the number of games is finite here. We have 20 games. So if we were to say that X is the number of games that Laura wins, then X can be stated to have a binomial distribution where N is 20 and P is 0.7. So for part 1, we're working out the probability that X is equal to 14, and then for part 2, we're working out the probability that X is greater than or equal to 14. Now, both of these calculations can be worked out very easily on the graphical calculator. I always go into statistics mode number 2, to do this. So it's the easiest way of doing the calculation on the calculator. So once we're in stats mode, we need to click on distribution, which is F5. We then need to choose binomial, which is also F5. And for part 1, we then want BPD, binomial probability distribution. The data should be set at variable. The X value is 14 because we're working out the probability that X equals 14. The number of trials is 20 and the probability that Laura wins is 0.7. This then gives us 0.19163 ... or 0.192 to 3 significant figures. We should round our answers sensibly to 3 significant figures, possibly 4 significant figures. And the probability that X is greater than or equal to 14, well, this time we want to do the calculation again, so following this system here, but we want BCD, binomial cumulative distribution. So we set the lower value as 14, the upper value as 20. There are 20 trials and P is 0.7, and this then gives us 0.6080 ... or 0.608 to 3 significant figures. You can also do the same calculations in run mode, but in run mode you have to memorise the order in which you input the various pieces of information, whereas in stats mode there is a prompt that tells you which pieces of information to put in which place. So it's much easier to do all your probability calculations in stats mode rather than in run mode.